busy as we go. This the first like hour.
Right. So everything is good, ready to go.
We're good to go.
Ready to go.
Have
you guys ever watched Thunderbird, like the old Thunderbird with all the
the
animated puppets and whatnot? Yeah. Yeah.
I think I watched that when I was like 4.
Hey.
You weren't even around then. So
No,
I mean,
I probably wasn't.
Thunderbirds are gold.
Yes. Okay.
Well, back then it was really quite the sci-fi show. I mean, there was nothing else. There was nothing. It was really the best show already at that time. All right. So we have new homework assignment. All right. And what we'll do is to talk about the concepts that we need in order to do the new homework assignment. So I want everybody to be aware of the new homework assignment. It will look completely foreign to you because we haven't really talked about it yet. Yeah, and yet it is assigned today so that you guys can pay attention in the class and see if you can work out the pieces of that homework assignment as we talk about the concepts. Okay, so that's due today. We'll talk about the solution today. And, well, let's do that first. Let's talk about the solution of the one that is due about 3 minutes ago. And then we'll talk about a new one. All right. This is the one that was due about 4 minutes ago from now. We'll go ahead and talk about the solution. Sometimes I may not grade your homework assignment, as early as I can, but I will always give you the solution first, just so that you know what the correct answer is. Then you can compare your answer to the expected answer, so that way you still know what it is, and hopefully you will still learn from it. All right, let's go ahead and work on the traces in this case, because we have 3 specific test cases. This is the first test case. The first test case is, I already know x is 1, y is 3, don't ask me why, it is a precondition, it is given to me. We start on line 1. Line 1 is the beginning of a conditional statement. We have to evaluate the condition, x is greater than y is false. Okay, then where do we go? We go to line 3, because the condition is false, we go to line 3 and evaluate that condition. X is greater than or less than y, which basically says x is different from y is true. So then we go to line 4. Line 4 changes z to a value of 4, and then where do we go? Post. We're done. Okay, so now we go to the next test case. Okay, start with line 1. X is greater than y is true. Where do we go?
Line 2.
Line 2, and that changes z to a value of 2, and then where we do? Post. So you can see that even though the algorithm is a little long, the second test case is really short, because we take the first one, the first condition, and then we exit. And here is sheet 4, which is our last test case. In this case, x equals 1 and y equals 1. On line 1, if we evaluate this condition, x is greater than y is false. We go to line 3, x is different from y is false. We go to line 5, x is greater than or equal to y is true. We go to line 6 then, and we change z to 6. And then we get out of the whole thing, post, we're done. Have you guys noticed that there's no way I can get to line, what is it? 8? Because we have just covered all 3 possible cases. Because when you compare 2 variables, you can either have one being less than the other one greater than the other one, or they're the same. We have already covered all the cases. So that means there's no way we can actually go to line 8 in this case. Now, is that a proof that we cannot get to line 8? It's not really quite a proof, okay? Most of you probably have the gut feeling that, yeah, I mean, looking at this, seeing that we have already, quote unquote, tested all 3 possible cases, there doesn't seem to be any way to get to line 8. But can you make that guarantee that given any value of x and any value of y, we cannot get to line 8? You can probably say that I have a gut feeling that that's the case, but you cannot really prove it, very, using rigorously using math. And that's why we are doing the pre and post conditions, because once we understand preconditions and post conditions, we can actually mathematically prove, regardless of the values of x and y, there is no way you can get to line 8. Okay, so that's the value of the next topic, the next thing that we're going to talk about. So before we move on, I'll save it into today's folder. This is a way for myself to keep track of what I have talked about in the class. And then we can close all of these windows. Get this one out of the way. This is your next homework assignment. Your next homework assignment looks about the same, but this is actually quite different. So let me go ahead and download this file and then show you what the question is about. This is actually not a spreadsheet because we are not tracing algorithms anymore. So that's the first thing you have to remind yourself, is we are not really tracing algorithms anymore. We're actually trying to figure out the pre and post conditions of each line in an algorithm. In this case, we still have an algorithm. Lines 1, 2, 3, 4, we have assignment statements only. We don't have any conditional statements nor loops in this case. And then the question is saying, start with a precondition of pre1 equals x equals 20. I'll explain what that means later on. Figure out what is post for step by step, and use all the conventions that we use in the class. So that means today we'll start to use those conventions. Each precondition except for pre1 needs to be explained. I'll also tell you what I mean by that. The derivation of each post condition needs to have the following. Does the right-hand side refer to the left-hand side? Let me kind of bump up the font size here. Is the function on the right-hand side reversible? We'll talk about that concept too. If the function on the right-hand side is reversible, what is the inverse function? Which rule should be applied? There are 2 rules that we can consider. The template of the rule applied to this case: substitute components with actual terms, carry out the operation, and conclude with the post condition. So these are all the things that I need for each derivation step. Okay, and we'll talk about that. I mean, this looks pretty abstract at this point, but it will not be so abstract once we start to talk about it. Work on the derivation below the following lines. So there is a place for you to put your content. So I'll just keep this one up for the time being, and then meanwhile we'll go back to the notes that we started on the other day, which is pre and post conditions. I also made some changes to this note today. So for those of you who have printed it out, you might have to print it out again because I have made some additions to the notes that was already there since last time. So let's go ahead and get started. I'm not going to repeat what is this crazy math. Essentially, what it means is if you want to become an effective software engineer or programmer or developer, you really need to have a strong background in math and also in logic. Okay, everybody can copy and paste code from somewhere else, like from a book or a CD-ROM or something like that, but not everybody can effectively figure out why a program is not behaving correctly. Okay, any questions or any comments about that? No one is going to claim and say, I never make mistakes when I write programs, and therefore I don't need to debug programs. No? Okay. Because in that case, I encourage that you work for Microsoft so that we don't have any problems with Windows. Okay, so let's talk about pre and post conditions. A precondition is simply what we know before the execution of a statement in a program. Well, that seems to be similar to what a trace is for. There's only one big difference. In the case of a trace, it is in a very specific case. Okay, everything has a concrete value when you refer to the variables. In this case, it's a much more general description, or much more general statement. A condition is what we know after the execution of a statement in a program. So it's the same thing. It looks like we're doing traces, but we are not. The analysis of the pre and post conditions of a program is essential, because this way we can prove the correctness of a program or an algorithm rigorously. In other words, how do you know our algorithm that finds the maximum of 2 variables will work in all cases? Well, I can kind of show that it works in one case where one variable is less than the other one. I can show you a case where one is greater than the other one. I can even show you the case where they are exactly the same. And I can still show you in all three cases that the right answer is in Z. But does that really prove that for the next pair of values of x and y, it will do the right thing? Maybe, maybe not. Okay. So if we rely on test cases, just as what I just did with the homework assignment that was due today, there's always a chance that you miss one test case. And that one test case will break the algorithm. It will behave incorrectly. But if we use mathematics to prove an algorithm is correct, then assuming the proof is rigorous and correct, then we can actually prove once and for all that an algorithm is correct. It will always do the right thing. Any questions about what we are going to talk about or why we are going to talk about this? No questions? Okay. We'll start with something simple, constant assignment statements. So instead of reading from my own notes here, once again, I'm going to use a live example that may or may not be identical to my notes, that is already up on the web. So I'll go ahead and start with something that looks like this. X gets a value of, say, 20. Okay. But this time, I'll give you a precondition. The precondition is I already know that y equals to, say, 40. And I already know that x is greater than y. Well, how about this? I say that x is greater than z. This is a precondition of line 1. All right. Well, that doesn't look like the precondition that we have been talking about in traces anymore. Because in a trace, when I talk about a precondition, each column has to start with either a specific value, like 3, 5, 10, or whatever, or a question mark to indicate that we don't know anything about that particular variable. In this case, we know something about y explicitly. We know y has an exact value of 40. That looks kind of similar to the precondition that we deal with in a trace. But at the same time, in the other one, the other condition is just that x is greater than z. I did not tell you the exact value of x, nor the exact value of z. I only know how they relate to each other. Okay, and this is something that we haven't seen because we have not dealt with anything abstract like that up to this point. Are there any questions? So combined, this entire line, what it means is before we execute line 1, someone will guarantee me that y always has a value of 40 and x is always greater than z. Yep.
So it does mean z going to be less than 20?
No.
No.
No. This is before line 1 executes. As a precondition, it means before line 1 executes, this condition is always guaranteed. Now in this case, because it is the line 1 of the algorithm, so that means the guarantee has to be made by an external entity, whoever is going to run the algorithm has to make sure this is true before we run the algorithm. But nonetheless, it is always known that y equals to 40 and x is greater than z, even though we don't know exactly what x is or what z is. Any questions before we move on? Then let me ask you the question, what is post 1? In other words, after line 1 executes, what can still be guaranteed in this case?
Y equals 40.
Y equals 40 can be guaranteed because the assignment statement does not even touch y. What about the other one? X is greater than z.
We don't know.
We don't know. Very good. Okay, that can no longer be guaranteed. Maybe it is still true, but since it cannot be guaranteed, I cannot state that anymore as the post condition of line 1. Is that okay? Yep.
Couldn't we say z is less than 20 then?
Z is less than 20 is no. Nope, that's not true because the statement of line 1 does not change z. It only changes x. So I can give you an example. Okay, in one particular case, maybe x was let's say 60, and z was 1. Okay? So after the assignment statement, the condition is still true because x is 20 and z is 1, so x is still greater than z. But I can have another specific case where x starts with a value of 2 and z starts with a value of 0. Well, that won't work. Okay, so x starts with a value of 30 and z starts with a value of 29. So that makes the condition true. The precondition is still true, but the post condition is not true anymore. Okay? So we are not looking at specific cases. We are basically saying, if I know pre1 has to be true before line 1 executes, what can still be guaranteed after line 1, immediately after line 1 executes?
X equals 20. X equals 20.
Oh, we know one more thing. Exactly. We also know from now on that x equals to 20. Does that make sense? So I have to get rid of one of the comparisons. The inequality has to go because it can no longer be guaranteed. However, I can add one more piece of fact because at this point I know for sure that x has a value of 20. Is that okay? All right. So given this, I can give you just another example. Okay, let's go to line 415 of an algorithm. I don't care what is before this. I just want to know what is guaranteed before this and what this statement looks like. So in this case, I can say x is, we are just dealing with constants right now. So for whatever reason, has to do with lines 1 to 414, whatever it is this part is guaranteed. We know x as a value, x is greater than y, and y is greater than z, and let's see here, z is the same as k. Okay. For whatever reason, due to the other 414 lines before this condition is guaranteed before I execute line 415. The question is, right after I execute line 415, what can be guaranteed?
X is 30.
Okay, so post 415. But can we still say that x is greater than y?
No.
No, not knowing anything about y, not knowing anything about z, I mean x, and now that we just changed x, that can no longer be guaranteed. Right? So that cannot be guaranteed. What about y is greater than z? Can that still be guaranteed?
Yeah.
Yes.
Yes, because we haven't changed either one of those variables. So whatever, if they were, they are still the same value at this point. What about this one here, z equals k?
Yeah.
Yeah, we can still guarantee that. And then we can add a new fact, as you said, that x equals to 30 from now on. Yep.
Did you say that y is greater than 42?
Y is greater than, there's no relationship between y and 30.
Why? We're not talking about 30. We're talking about y and k.
Say
I
again?
don't know if you would want to put that in there, but if y is greater than z and z is equal to k, then y would also be greater than k, right?
Yes, you can do that. You can state that too. Correct. What her point was, we can also state that y is also greater than k. That is correct. Okay, very good. But it looks like, with assignment statements like this, sometimes we have to forget certain parts of the original condition and then add one more part to it. Let me give you the last one, which looks awfully confusing. Okay. The assignment statement itself is not the problem. It's the precondition. The precondition of line 1 is simply true. What am I saying here? Now, but you have to kind of keep in mind what a precondition is. A precondition is nothing more than a guaranteed condition before a particular line executes. So in this case, I'm just saying before line 1 executes, true is true. Am I saying anything about any variables?
Nope.
That's exactly what it
We don't
means.
even have a check.
And that's exactly what it means. That is exactly what it means. It simply is saying we don't know anything about any variable at this point. Is that okay? Because it looks really confusing. I mean, what are we saying here? Well, all we are saying is we know nothing.
So we could say that we know nothing is true then.
No, we know nothing about the variables.
Okay.
So I can only guarantee you one thing. I can only guarantee you that true is true.
That you got to know.
Okay? Now, but by that, even by itself, it is still a very important statement. Because when I say the precondition of a line is true, that means at least you can get to that line. Okay. Now let's work out this case first. What is post 1 in this case? Is there anything I have to get rid of from true?
X is 5.
X equals 5.
But we can add the fact that x equals 5.
Yeah.
So technically speaking, we have to say true and x equals 5. Because whatever was true that did not depend on x still has to be true. But what is true and x equals 5? Can we simplify that? It is simply x equals 5.
So you don't have to state the truth.
Right, because true and anything is anything.
Yeah.
It's just like, 1 times x is x. 1 times whatever is that whatever. How do you call 1 in multiplication? There's a particular name for that. How many people have taken algebra in high school? So how do you call 1 in the case of a multiplication or 0 in the case of an addition? It's the identity. Yes, very good. And in this case, true is the identity of conjunction. False is the identity of disjunction. Because false or anything is just that anything. All right. All right, since I said a little bit earlier that the precondition being true is still significant, let's look at one other case, which is line 56. On line 56, x gets a value of 7 for whatever reason. Okay, the programmer said I want to make that line that way. But the precondition of line 56 is false. Okay, what does it mean when the precondition of a particular line in a program is false? Let me rephrase that question. How can I guarantee the precondition of a particular line is? How can I guarantee you false is true? That is the question.
Okay.
Never. The answer is never, right? False can never be true. So what that means when you have a precondition of a particular line being false, that means line 56 is at least a part of a dead branch. We can never get there when we execute the program, guaranteed. Okay? Now, does this ring a bell, the word or the phrase dead branch? Does it ring a bell? Something that we have been talking about a little bit. Even today, when we talked about the solution of the homework assignment, I said line 8 is a dead branch. So that means after we learn everything about pre and post conditions, we should be able to prove that pre-8 is false. And therefore, we can actually claim that line 8 of the homework assignment is a dead branch. It doesn't matter how you initialize x or y, there's no way you can get to line 8 when you execute that algorithm. So we'll probably go back to that point maybe sometime next week, because I don't think we'll have enough time to cover conditional statements today. But we'll get back to that point. All right. Okay, so what we can do now is to generalize stuff a little bit here. So I'll just use n here to represent the line number, and we'll use a particular statement here. And in this case, k is not a variable. K represents a constant. So let me just add here. N is a line number, and k is a constant. Okay, it's a number, 5, 10, 20, minus 5, whatever. So in this case, the post condition of this line, which is line n, is going to be based on the forget operation based on the precondition of line n. And in that precondition, we have to forget everything that we knew about x. But we also want to say that after we forget everything that we knew about x, we just want to add one more thing. From now on, x equals k. That is what we call the forget rule. So let me just put it here first. The forget rule. This is all in the notes. I mean, this is not, if you read the notes, it's all there. It's just presented in a slightly different way. This is a template. Okay, we like templates in programming. We like rules and we like templates. Why?
Consistency.
Consistency? Well, it's mostly because computers are very, very good at following rules. You specify the rules, and if it is not ambiguous, it's precise, the computer has no problem, following those rules either. So every time we can specify a template, specify a rule, it's actually good because it means every time you encounter a situation like this, you can apply that particular operation. Okay? Yeah, that's it.
Got some bad termites.
When I was a kid, mechanical pencil was really, really the cool thing to have. Okay.
Get 2 pencils sharpened.
That's why I keep a pocket knife.
Really going at it.
That one.
Yeah, I know. I was like, really?
That's how I keep it.
Take it out of context, I'll be dead.
Yeah.
All right, so this is a template. Every time we have, an assignment statement that involves a constant on the right-hand side and a variable on the left-hand side, but that's a given on a particular line, and we can apply this operation. So the next question is, what exactly is the forget thing? I mean, everything else we can kind of. So let me just explain what this is. It's also written in the notes, so it's already online. Okay, means. Okay, remove all components that refer to variable x in pre-n. That's all it means. Okay. So now let's go through one example. Let's pick one of the things that we've worked on already. So I'll go ahead and pick this guy here. Copy and paste. All right, let's work on this one. First of all, does it fit the template? Okay. In other words, we look at 20 here. Is 20 a constant?
Yeah.
Okay. Line 1 is the line number, so everything fits. We are dealing with a constant on the right-hand side. So what that means is I can write the post condition of line 1 is the forget operation applied to the precondition of line 1. We are forgetting the components containing x, which is the variable that we are changing here. And we are also adding the fact that x has to equal to the constant. In this case, the constant is 20. Is that part okay? Does everybody understand what I just did here?
You're basically just stating what was already stated or what was already implied by replace x with 20.
Exactly, but I'm just making it very mindless because if I see this, I can apply this rule. If I see this, I can apply this rule. That's what I'm trying to do, is to make up a bunch of rules so that when we see an assignment statement fit a particular template, we know what to do with it. Yes?
You're not forgetting about the y variable.
Oh, we're not forgetting anything yet, okay? Because all I'm doing here is to refer to pre1 just as pre1 itself, okay? In the next step, you made a very good point. In the next step, we have to expand the term pre1 to the actual meaning of pre1. So that's a very good observation here. So the next step is to say forget, but this time I can use this expression in place of pre1 because we already know what pre1 is. And then still put an x here because this x here is important because it tells us we have to forget all the components that refer to x. So that's why it is still here. And x equals to 20, which is outside of the forget operation. The forget operation is this part of the conjunction, and this is outside of the forget operation. It is very important to remember x equals to 20 is outside of the forget operation.
But then we're forgetting that y equals 42.
Yeah.
No, it's
Just refer for s.
We keep y equals 40 because the operation is only to remove all components that refer to the variable x in the precondition. Y equals 40 does not refer to x, so we get to keep it.
But we still have to put that in the forget.
Yes,
So we just take out everything that has to do with X and leave what was left.
exactly.
Okay.
In other words, it's kind of like a filtering mechanism. So the forget operation will give you only this part left because the other part is forgotten. And then we also have the other side, which is outside of the forget operation.
Okay.
Okay?
But it looks like it's inside the way it's in all in parentheses.
It is. It's just forgetting X, but leaving 40.
Do we have to go through all that? Because you just narrowed it down to the same thing as the top.
Yes, but you still have to go through the whole thing because I want you to show the steps. Yep. It's okay. You're going to work on it using LibreOffice, so you can copy and paste. Copy, paste, and modify. Yep.
What if, for the forget, we have no x, we just have y, z, and say k? Would it will apply to that, or is that just a wrong pass?
Any condition that involves x, we have to forget. The variable that is being changed, we can no longer guarantee its conditions. The conditions that was true, we can no longer guarantee those, in general.
Well, what if there was no x?
If there's no x, you keep the whole thing. Yep.
But can you remove like more than one variable?
No, because, well, you can remove more than one conditions because x may appear in multiple conditions.
But I mean, like if you had like x, y, and k, right? And then you said that remove pre.
No, the question is how do those variables relate to each other? Okay, the question is how do they relate? If they have no relationships to each other whatsoever, you just simply say that x equals 1, y equals 20, and z equals 40, and you're only changing x, then you only have to remove that one part that mentions x. The other two gets to stay. You have to remember why we are doing this. We are doing this so that, something that was true before the statement that may not be true anymore, we remove those components. That's why we are doing this. So you got to remember why we are doing it. This is just the mechanical part, but you have to remember why we are doing the mechanical part of this operation. I can give you guys more examples. I mean, that's not too hard. Line 5. Line 5 changes, z to a value of 4. The precondition of line 5 is, let's make this simple. Okay, x equals to 0. For some reason, we know x equals to 0 right before line 5. Okay? What is post 5? Well, when you do your homework assignment, you have to do the whole thing. Okay, so you have to say post 5 is forget pre 5. Anything that mentions the variable being changed. So what should I put here? Z is the 1. And after this operation, we know that z has to equal to 4. What exactly is pre 5? Pre 5 is just x equals to 0, nothing more than that. And since the forget operation is only forgetting components that involves z, is there anything here that I should forget? Nope, because x equals to 0 does not involve z. So we get to keep the entire precondition in this case. X equals to 0 stays, and then we're adding the fact that z equals 4. Is that okay?
Yeah.
Can you post this on Doodle?
You mean
this file?
This file? Yeah, you can do it. Let me make sure I save it first, because if I don't save it first and then I shut down the computer, it won't remind me to save it.
Are you recording right now?
I am recording. You can actually reconstitute everything from the video too.
That's true.
Are you uploading as you record right now? The video?
I wish I could do that. That would be like really cool if I can just stream it to YouTube, so it would be recorded by YouTube. But I haven't found a way to do that yet.
How long?
There has to be an API to do it, huh?
You should do that to charge money.
There has to be an API to do it, because I know they have an API to use webcams to stream directly to YouTube. So if you can stream using a webcam, you can do the same thing with the screen recording, because I can everything can get basically massaged into the same stream. I just haven't found the correct API to do that yet. API stands for Application Programming Interface. All right. So now are we ready to deal with more than one statement at a time?
Yes.
Okay. Let's do something simple, okay?
Simple, overrated.
Yeah, something that's really kind of dumb.
Plus participation.
Oh, okay, how about that? Okay, so I'll just go ahead and change the size a little bit so that, because it's maximized, it won't let me change. There's no resize button.
That's all right.
Probably font size.
What about the scroll? If you hold.
There we go. There's always a way to get around. All right. Okay, that looks really simple. You guys know how to trace this already. But I don't want to trace. I want this to be in pre and post conditions. Okay. So there's a whole lot of typing. Copy and paste. Basically in this case. I do have to tell you what is the precondition of line 1. I'll just use this case. I don't know anything about any variable before line 1 executes. Or just to say it's true. So post 1, according to this, is the forget operation applied to pre1. We are forgetting everything that mentions what? X, which is the variable being changed. And after this, we can also state that x equals 5. That's pretty easy. So in the second line, all I am doing is to convert pre1 to whatever it is. It's a simple substitution here. And then on the next line, I'm saying, okay, does true mention anything about x? No. So we keep the whole thing. And because true is the identity of conjunction, true and anything is just whatever is left here. So we have simply that expression. Now, how do we start with pre2? Whoa, Jack, we don't know how to make the connection here.
Well, pre is just the post from line 1.
Yeah.
Exactly. Okay. So does everybody think that it's fair for me to pass the row sheet at this point?
Oh yeah.
Okay.
I thought it was actually rotation.
All right. So pre2 in this case, because you cannot get to a post condition without a precondition, you always have to start with a precondition. But in this case, pre2 is post 1 by definition, because line 2 follows line 1 immediately. In other words, if I can guarantee a particular condition right after line 1 executes, it's really the same condition that applies to right before line 2 executes. And that's why pre2 is the same as post 1 in this case. Now that is not always the case. Once we factor in like conditional statements and loops and stuff like that, it is not always guaranteed that the precondition of a line is the post condition of the line before, because we can have else, then, we can have while and stuff like that. So that may not be true anymore once we get into the other control structures. But at this point, we only have sequences, so that can be guaranteed. That's easy, because we already know that it's simply x equals 5. That is what I mean in the homework assignment when I say you have to explain what a precondition is. You just have to relate it to the previous line. Simple as that. All right, so now that we know what is pre2, we can try to figure out what is post2. First of all, does it fit the template? Does 4 look like a constant to you? So if it's the template, we apply the template. So we say post2 is the forget operation applied to pre-what?
Pre2.
Pre2, not pre1 anymore, because it is the precondition of the same line. And we are not forgetting components mentioning x anymore, because on line 2, y is the one being changed. So we have to forget components that mentions y. And then after that, we know y equals to the constant 4, because that's all the line is trying to do. The next line is going to expand what is pre2. Pre2 is just x equals 5. So there's really nothing to forget, because x equals 5 does not mention y. Yes?
In our homework, do we have to put the spaces between the lines of like pre2 and post too?
It just makes it easier for me to read, but it's not mandatory. The spacing is not mandatory. Yep. So x equals 5 stays, and then y equals 4 is the one that we have just added. Is that okay so far? All right. So now we can work on the last one on line 3. Pre3 equals post 2, because these two lines are sequential. They're right next to each other. And because we know post 2 already, we can just repeat what post 2 is in this case. Then we can say post 3. Well, can we apply the forget rule to line 3? Does it fit the template? It fits the template because the right-hand side is a constant. Okay. So we can use the same rule. We apply the forget operation to pre3 in this case, because pre3 is the precondition of the same line.
X.
And which variable? X is the one, because we are changing x again. And then after that, x equals to 3. Very good. And then we go ahead and expand it. And because your homework assignment only needs to be done in a word processing document, you can copy and paste just as I did here. So it's not, hopefully it's not a whole lot of typing. All right, but this time we do have something to forget, don't we? Because inside the forget operation, this is the precondition, and I'm trying to forget components that contain x. Oh, the first one does contain x, so we have to get rid of that one. So after the forget operation, what do we have left?
Y equals 4.
We only can keep that one, but we are also adding the fact that x equals 3, so that's the end of it.
You keep x equals 3 because it's outside the forget.
That is correct. X equals 3 is outside of the entire forget operation. Yep.
So if x equals 3 is outside the operation, should we forget x is 5 and y is 4? And we'd be left with x is 3 only?
We only forget x equals 5 because y equals 4 does not mention x.
But it's still inside the forget operation.
It is still inside the forget operation, but the forget is selected.
Yeah. Okay. So it's not
It's
forget
more like
everything inside these parentheses. It's only forget
The condition. The
Whatever you
condition
designate.
And therefore,
whatever matches.
yeah, and therefore we have to mention what we are forgetting, because otherwise, this component would be useless.
Yeah.
And that's why we have to specify. We only want to forget things that mentions x. Okay. Very good. So we got quite a bit of stuff, cleared away at this point. Now let's move on to something that looks a little bit more sinister.
Oh, yes. Awesome.
Sinister is good. Because,
Like
if you think about it, if your entire program consists of assignment statements with constants on the right-hand side, I don't think that's going to be a very interesting program. Okay, so let's go ahead and do something that is just slightly more interesting. From the perspective of programming, it is just slightly more interesting. But from the perspective of pre and post condition, this is a little bit nasty, don't you think? X gets x plus 1. Well, let me give you the precondition first, and then you can tell me what the post condition is. So we'll go through a few examples, okay? We'll go through ones that are very, very simple first, and then we'll crank up the difficulty level, in the next one, okay? So we'll say in this particular case, for whatever reason, the precondition of line 2 is, I can always guarantee you that x equals 3. In other words, just like the precondition in the previous cases, this is stating that every time I get to line 2, I can always guarantee that x equals 3. Okay? Now, what is post 3 in this case? X equals 4. Very good. So we are not too worried about the derivation at this point. I'm just getting to the result here. We know that from tracing too, right? I mean, I can trace this particular line. X, the column of x has a value of 3 at this point, and then after line 2, I just have to update that value to 4, and I'm done. That's pretty easy. Let me try something else. Line 31, whatever it is. Z gets z times 2. And let me ask, I'll just make this one a little bit more nasty by stating the post condition, and then you have to tell me what is the precondition, all right? The post condition is z has a value of 40 at this point. Can someone kind of reverse time here and tell me what is the value of z?
20.
20.
20, right? Does it make sense? After we double the value of z, we have 40. So before we double the value of z, we have half of that, which is 20. So it makes sense, right? So I'm just exercising your logic, so that you can go, you understand how to go forward. Given a particular value, you know how to go forward, and and also backwards. Now, going backwards is actually particularly important in programming. Why do you think that is particularly important? For debugging, okay? How do you debug a program, by the way?
You get the output and you have to figure out where it screwed up.
Yep. Well, first of all, what is debug? What does that word mean?
To remove the errors.
To remove a defect, okay? A bug is basically a defect. A bug does not always necessarily cause a crash or even something that is visible. It is simply your program not doing what it is supposed to. That's a bug. So debug is the process to remove defects of a program so that it behaves the way it is supposed to. Okay. But how do you know your program is not behaving the way it is supposed to? How do you know?
It doesn't give you what it's supposed to.
Well, at some point there has to be a symptom of some kind. Okay? There has to be a symptom that gives away the fact that your program is not doing what it is supposed to. Sometimes it's a crash. Okay? You get a, in Windows, how is it called? A general protection fault.
I was going to say blue screen or death.
You get blue screen of death sometimes, but you can also have the applications that's dying on you, which is called a what? Is it a GPF? General protection fault? I'm just trying to come up with a term that Windows call that, because in Linux land it's called a segmentation fault. But nonetheless, your program can crash, and the program will go. Sometimes it will give you a hint, like your program just crashed on line da 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 da. Okay. Other times it is not a crash. Some other times it's simply the program not working correctly. It's giving you the wrong output. Okay. Do you think the bug is? Oh, go ahead.
Oh, I didn't have a question.
Oh, okay. So do you think the bug is right where the symptom happens?
No.
No. How far do you think a bug is in general from where the symptom starts to appear?
Anywhere.
Could be any.
Exactly. In other words, if you look at the path, if you look at the trace, now that we have talked about traces, so if you think about the trace, which is a really, really long spreadsheet, with really big, long columns, okay? This is where the program starts, and let's just say that this point here is where the bug shows up. So this is a little skull, okay? Okay. This means, okay, at this point, you notice something is not right with the program. The program crashes, you get a screen saying, something is not right on this line, or you just notice that something is not correct. Okay, it's not behaving correctly. But the actual bug, in other words, the defect of the program, of your algorithm, can be anywhere along this line. It can be all the way up here. It's just that the effect of this wrong logic here is only shown all the way down here. So go ahead.
So depending on where the bug is, whether you're using post or pre, using the order you're using it in.
Well,
because 2 you did post or pre then post, and then 3 one you did post and then pre.
Yep. You're trying to okay, in a case like this, now hopefully your bug is not all the way up here, because if it is all the way up here, it's going to take a long time to get it back up there. So maybe your bug is here in the execution path. Everything up to the blue line is okay, it is all correct. But on the blue line, this is the faulty logic is specified on the blue line. Okay? So the blue line is what you want to find in order to fix the defect in the program. Yep.
I have a question. If you were debugging, wouldn't you start from the beginning and go all the way down and then start going back and start debugging? Wouldn't that be
It's really hard to say. It depends on the situation. It also depends on your experience with programs. So sometimes with certain types of symptoms, you go backwards, and with certain other symptoms, you just have to start from the beginning and you start to analyze it. It's not unsimilar to performing diagnostics on cars. Okay, so one day you start your car and the engine is starting up rough. Okay, there's a lack of power when you try to accelerate. How do you diagnose the problem?
You start with basics. Start with basics.
Start with the basics, okay? And it's the same way with programming. You start with the basics. But different people will try different things because some people have bad experiences with, let's say, spark plug cables. Because a bad spark plug cable can lead to a problem like this. Because if you have, especially when you have a little 3-cylinder engine and one is not firing, you would definitely notice. My roommate used to have a Thunderbird, one of those really old Thunderbirds, and it was a V8. When by the time we discovered it, it only had 5, firing cylinders. Yeah, 2 were gone, and we hardly noticed anything. By the time the 3rd one was gone, we started to go like, the car isn't idling very smoothly. What's wrong with it? And then we open up the hood and go like, whoa, okay. So depending on your experience, you may try different things first. Look for different types of problems first. So it's really hard to teach debugging because a lot of that is based on experience and also what type of problems you are exposed more to. You see? But nonetheless, in this case, it would be nice if we can somehow go backwards in order to get back to this blue point here. Attack is easy to get back to the blue point because we have the whole trace. So all we have to do is to look, and start to look up. Start with row 2020. And then go up to 2019, 2018, 2017 until we find a line that's, oh, this is not what I wanted to do. There's a problem with that logic. Where's your trace? This is the real world. If this were the real world, there's no trace. A trace that we do in this class is a completely artificial thing that we do in this class so that you can show me that you know how to follow the logic of a program. When you move on after this class to CISP 360, 400, 401, 430, and so on, and then eventually get out of college, university, and get a job, there is no such thing as a trace. So now you're stuck with what? You're stuck with that. You're stuck with a bug, the symptom of a bug, not the bug itself, and when it happens. And that's all you have to start with. And that's why it is so important to know how to diagnose a program going forward and going backwards and apply logic as much as you can to try to find out where is the source of the problem. Okay? And that is the reason why we have to go through all these pre and post conditions and stuff like that, is to really train your logical thinking so that you can think in terms of, okay, if I know I can get to this part, I must have gotten here because of that, and so on and so forth. All right. So let's move on with this one. And the next one is going to be a little bit more nasty. So we are just increasing the difficulty as we go along with these examples. Let's start about line 314, okay? Just randomly. And in this case, I have x gets x plus 1 again, except the precondition of line 314 is saying, oh, I only know one thing, x is greater than k. So what should I say in post 314? Say again? Say that again. I know you're pretty close to the answer. Okay. So he said x plus 1 is greater than k. But that's actually the opposite.
Backwards.
That's the opposite. You're very close, but the answer is actually x minus 1 is greater than k. Whoa! That's counterintuitive. The statement has a plus, and how come the post condition has a minus? Yep.
Because you're referring back to the precondition.
because I'm undoing the effect of that line so that I can maintain the relationship between x and k. Okay? Let's think about it this way. Okay, let's think about it this way. Well, let's see. I'm trying to think of a real world analogy so that you guys can remember. Okay, let's try. Okay, let me change this one a little bit, and I will just say that x is less than k to begin with, and this will also be x is less than k. All right. Okay. This actually I can make an analogy that will make it stick. Okay, you will actually remember why that is the case. Okay, k in this case is my height. Okay, do you think next year I'll be any taller?
Probably not.
Probably not. Unless someone saw off my legs and graft something else on it. I don't think I'll be getting any taller. And let's say that x is the height of my daughter, who is 11. Okay, so she's still growing. This statement is saying in 1 year, her height will increase by 1 inch.
Okay.
Okay, that seems to kind of fit the picture, right? The precondition is saying that she, last year, she was shorter than me. Okay, the statement is saying this year she grew by 1 inch. Okay, so after she grew by 1 inch, what can I still say? I don't know whether she's actually taller than me this year or not, but I can say one thing. If I subtract 1 inch from her current height, that number, after the subtraction, the difference, will still be less than my height. Is that making any sense?
No.
Real world, no.
Huh?
So how are you going to subtract 1 from her height?
What?
How are you going to subtract 1 from her height? I don't.
What are you gonna do?
Isn't it just a negation of
Yeah.
the minus one?
You're just
statement?
Then it
undoing
would
what the
still be-
statement is
Yeah,
doing.
it's the same thing as it was
Yep.
before.
Yeah. Okay.
Okay.
Because you
Then
know
why
that
even
you-
have the line in the algorithm then?
Because
Good question.
you have to have.
Yeah.
So we're trying to prove that the current condition of x is less than k, so x minus 1
Yeah.
will still less than k.
versus
Yes.
you have-
Now, the most important part, I think I know where the confusion is. This x refers to the value of x after line 314 x.
Yeah.
In other words, it refers to the height of my daughter this year. This x here, because it is a part of the precondition, refers to the height of my daughter from last year.
Okay.
Okay, so this is her height this year. She grew by 1 inch over the past year. This number is really the same as this number here.
X minus
Yeah.
1 is the same.
Is that making any sense?
So it's like +1, but the new value x you have to make a -1.
It's to undo what happened this year,
Okay.
so that I can still say something about x minus 1 and k, because k did not change,
Yeah.
but x changed.
Okay.
But there is a way for me to reverse that change so that I can say, if I reverse what happened to x, that quote unquote reversed version of x will still be less than k.
Okay.
That is the essence of what we're doing here.
So you don't just forget k then and say
We don't forget.
x plus 1 is the post.
We don't want to forget unless it is necessary.
Okay.
Okay? Yep, go ahead.
So could it be read just sort of like before the execution of 314, x is less than k, but after the execution of 314, x minus 1 is less than k.
Yes.
Say less than.
The value of x after line 314, immediately after line 314 minus 1, that number, that expression, is going to be less than k. Okay, so let me just write here, this is not in the notes, so I'm just adding here. Okay, and I'll just say x refers to the value of x immediately after line 314 executes. Okay, because that's a very important part. I mean, if you think about x, the value of x is changing all the time. When we talk about post 314, that is referring to the value of x after line 314 executes. When we talk about pre 314, it refers to the value of x before line 314 executes. Is that part okay? Yes, go ahead.
It's clear if you say that s minus 1 refers to the value of s.
The value of x before line 314 executes is the same as the value of x after line 314 executes minus 1. That is what it's saying.
But why you put s refer to value of s? Is s minus 1 refer to the value of s?
No, this x here by itself refers to the value of x after line 314 executes. Yep.
Can you give a different example?
Similar to this one, but completely different example, because that's.
Why don't
Okay,
you do the
looks like-
same thing, but we'll replace the variables with actual values?
Because that's what I've been doing in my head, and that's like, that doesn't even
but
make
that
sense.
destroys the whole property of the discussion. Because once you substitute with actual values, then in your mind you will go like, oh, I can trace. The
But if
whole
you
idea
substitute with
is,
actual values, it should still be the same, and it's not. That's what we're.
but you can no longer, but in your mind you will try to trace it if I use actual values.
You should be able to trace it regardless.
No, this is not traceable.
Yep, we're not tracing. That's the problem I think everybody's having. We're not.
Yeah.
This is not a
This
trace.
is a single
All
line. You can
all
trace
post
this one.
314 is asking is what do we know to be true? And because
Yep.
we modified x during 314, now afterwards we have to look at x as a totally new number. So
Mhm.
when we say what do we know is true, we have to say, well, because we added 1 to x, the only way we can know for a fact that x is less than k is if we subtract that 1 again. We're not
Mhm.
tracing. All we're doing is asking what do we know is true.
Exactly. Is that very good? I'm hoping the recorder picks it up. So next year I can just say that.
There you go.
Yep, go ahead.
Me?
Yeah,
So if we're not tracing, then we're just proving that.
we are proving it.
Okay. So,
Yep.
All we're doing is asking what we know.
So
What
this
do we
is like we're
know?
pretending that we have an algorithm and we're trying to see if it's working. So in the process of trace, we're just trying.
Right,
to
so what do
prove
we
that-
know before this line happened, and what do we know after this line happened?
Okay.
And if we get something
Okay.
different than what we think we should know, then something's probably wonky and there's a bug.
Yep. That is exactly
That makes more
what it
sense.
is. And it goes backwards too. This logic can also go backward and forward. Yep.
So I think I understand what he's trying to say. So it's like saying taking 1 to the other side, subtracting 1 from each side, we get x minus 1 kind of algebraic formula. That's where we got x minus 1. It's less than k. No?
It is reversing the operation on the right-hand side of the assignment statement. So that, because k has not changed, right? K is the same, the statement did not change k. Yeah, go ahead.
I had a question. I mean, like, what if you? I understand it, but I'm saying, like, what if you just change the 2 different x's to different letters, or different variables? Like, say,
In
like
here?
the new x is a different variable from the old x. That might be easier to understand.
But it is the same variable, so I
I know.
can't
I
really
mean,
change
like, but
it.
there are different numbers at the end.
In different numbers.
Because you're referring to the new number at the end and the old number at the beginning, and they're both the same max, and they're looking at it the same as the same number. Like how you stated up there, how they're how it changes immediately.
Okay.
Like everybody still sees it as the same variable in their head.
What about this? What about I change this so that in addition to saying that, I also set x equals 2 in this case. Okay? So in the next one, I can also say and x minus 1 equals 2.
Yep.
Does that make sense?
Yeah.
Is that better?
Yes.
Okay. So that means, but this is important because that seems like, every time we see x in the precondition, we can just replace it with x minus 1 and everything is still good. Right? Because x minus 1 is what reverses the operation so that x minus 1 as an expression is referring to the same value of x that is before the operation, before line 314. We are looking at undo. Okay, we're undoing what line 314 has done to x, and then say, oh, if we know what line 314 is doing to x, if we undo that, then whatever the relationship was before line 314 will still hold. That is what we are doing here. No? Yes? Kind of?
So you're still trying to keep the relationship between.
We're trying to maintain as many relationships as possible because they are all valuable. Okay? Because at the end of the day, what if magically I can do something like this? At the very beginning on line 1 of an entire algorithm, maybe a complex one, maybe a simple one, I can describe by the time line 1 executes, all of these conditions have to be guaranteed by whoever is running the algorithm. And then I go through all these crazy derivations, and at the very end of the entire algorithm, I have one single post condition. And that post condition says x has to be greater than y has to be greater than z, and blah, 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 blah. Okay? Let's say I can magically do that. What if the post condition is exactly what I think the program should be doing? What does that mean?
Means you're wrong. If there's a bug.
No. What if the post condition of the algorithm, using math like this to derive it, what if that post condition is exactly what I think the algorithm should do? Okay, let me ask you two questions. One is, oh, this is good. I can just say that the program is done and I can move on. Or two, I need to feed in some test cases to really test whether the program is working correctly or not. A or B?
B.
It's A. Okay, if you can mathematically prove step by step using this sort of logic, and you get to the end of the entire algorithm, and the post condition of the entire algorithm matches what you expect from the algorithm, you have just proven the algorithm is going to do the right thing regardless of how you feed the input into the program. And therefore, no test cases are needed anymore. Now, since we don't need test cases anymore, there's no danger of missing test cases anymore. This is otherwise known as the holy grail of software engineering. Because if we can prove whether an algorithm is correct or not, at least we can say, oh, okay, we can now release this program. We may not know how to fix it, but we know it is not right. Okay? It's also called program verification. This is called program verification. Doing it by hand is going to be very tedious and not very feasible. And that is also why in the artificial intelligence field, many researchers over the past decades have been trying to do something like this using computers, using AI. So you basically give an AI program an algorithm, and then the AI will have to derive the post condition of the entire thing. So you only have to look at the final solution, the post condition of the whole thing, and see if that describes what the program really should be doing. If it does, the program, the algorithm is done. It has to be correct.
So it's a program to check a program?
Yes. It's called program verification. And there's a programming language invented just for that purpose too. It's called Prolog. Prolog is the programming language that was invented just for that purpose.
Just for AI? Just
For that particular branch of AI, to be specific. Because there are different branches of AI. This is what we call hard AI, because it's basically just math. I mean, there's no real intelligence. The computer can try to prove theorems in different ways that you and I try to prove a theorem, but in the end, if it can do it, that's all we care. Just like playing chess games, if the computer can figure out what is the best move next, hey, it's all the same, even though the computer works quite differently from how we think when we think about a chess move. There's also the other side of AI is called soft AI, and that branch talks about how to use computers to model how we think. Okay? In other words, can you teach a computer to be humorous? Can you teach a computer program to understand humor?
Yes. No. Not at this time.
Well, there are researchers doing that sort of research. Okay?
That's what you think humor is.
There are people who are making computers to interpret human emotions. There's a practical application to it. Basically when you're using a computer, when you're interacting with a computer, if the computer can tell that you are tired, like such as all you are right now because you're in a class and I'm teaching the class, or you are frustrated, or your emotional state is changing, the computer can try to adjust how it responds to you to improve the effectiveness of the user interface. Yep.
It's like that new car that has that feature that if you start falling asleep, it'll beep at you or something like that.
You'll just deploy the airbag. Well, I think in the future, in the near future, I would give it maybe 5 years or so. The technology that Google cars or Street View cars are currently using will actually be in production. In other words, in a dangerous situation, when your car is approaching the car in front of you on the highway or a curve, too quickly, too fast, the car can just take control and do what it thinks is best for emergency handling.
So the Google cars were like intercepting all kinds of emails and passwords and stuff like that. They were investigated by the FCC and dropped. So they were doing all kinds of bad things with their cars.
With their cars?
Yeah.
Well, that technology.
Wi-Fi or driving.
Mm-hmm.
Yeah. You know why they were doing that? The improving your GPS signal on your phone. They used the Wi-Fi signals, and it was cataloging where all the Wi-Fi signals were along
That doesn't
route.
surprise me.
Yep.
That doesn't surprise me at all.
So it's storing all the SSIDs and all the the 6, is it the MAC address of each station. So it's storing all of that stuff to improve the effectiveness of being able to, so that you can locate where you are quickly.
Based on Wi-Fi.
Based on Wi-Fi, but it works relatively well. That actually works relatively well. Now, I know this is a hard topic and most of you are kind of tired right now. So I don't need to be an AI that can read the emotion to kind of tell the people going like, yes. Okay.
Still trying to remember the concepts.
Yeah. Well, but you do have to understand the concepts. Okay. Yep.
Since we're kind of like running out of time, could you maybe just give us a homework of what if we don't get to them?
Sorry. Yeah, there'll be an extension to the homework, since we cannot cover all the topics today. Is that what you
I was
asked?
just wondering, like, you probably have more of these written down that you haven't given us yet?
No, it's all here. The notes actually has everything that you need in order to do your homework, but I want to be able to cover everything before I give you the 1 week due date of the homework. So the due date of the homework will actually be postponed by at least 1 class period. So it will be postponed to Thursday. Yeah, because on Thursday I'm pretty sure we can cover all the topics that we need for the homework assignment. So for the time being, for the next 5 minutes, I just want to share with you something related to what we just talked about. But I think you guys really need to know all this stuff here. Some of you already know because you checked Slashdot and Ars Technica and Wired and stuff like that. You guys know about what a UAV is, right? UAV is unmanned aerial vehicle. Okay, and we know how the U.S. Army has been or Air Force has been using UAVs extensively these days. Air Force pilots are no longer quite the same as the Top Gun pilots in the movie Top Gun. Okay, they're more like you and I. Probably wearing glasses, driving our Prius to work. Sit down in front of the console, and then have a little joystick and drive around those UAVs. Okay, so UAVs are very useful in many applications, not just in the military. In Iran, do you know what the Iranian government did? They have a competition. The government funded a competition, just like we funded what's the name? The Grand Challenge, the DARPA Grand Challenge. So they funded a competition so that they invite. It's an open invitation. Everybody who wants to kind of quote unquote play and compete can do it. So they have a competition of these UAV competitions. So it's open class. Anyone can compete. And I think the game is locating in a certain area, a particular landmark, and so people have to build the UAVs. Actually drive or pilot the UAVs and look for that landmark. And what they found was once you have competitions like this, technology just goes like that. It just soars, very, very quickly. How many people know of what is the DARPA Grand Challenge?
I don't know what the grand one is, but I've heard of other DARPA challenges.
Okay, the Grand Challenge was the first one. The first one that it was intended because the reason why the DARPA has a Grand Challenge was after they dumped billions and billions and billions of dollars on defense contractors to have how do you call those things?
Auto navigation.
Autonomous vehicles, autonomous land vehicles. There was nothing. Okay, the best they could do was a little car that can follow you. Wherever you go, the car goes. Okay, I could have done that with a little wagon, right? So they were sick and tired. So someone working for DARPA was thinking, hey, what about this? We just put up $1 million as prize money, and we'll just have an open invitation to all universities, defense contractors, high schools, individuals, whoever wants to play. And we'll just have a competition. We'll start from here, and we'll have to end up there, and it's a race. So that's the first DARPA Grand Challenge. It has to be fully autonomous. The vehicle cannot be remotely controlled. Okay, you can program in the GPS locations, and that was it. The first year was bad. Okay, the best vehicles went about 7 miles, and they all went dead after 7 miles.
Did you see the one that was a motor? They just did a motorcycle,
Yeah.
autonomous motorcycle.
Yeah. Yeah, there was a motorcycle that can self-balance too. It didn't go too far though.
No, it didn't. But it was
Okay,
cool.
so that was the first year.
Okay.
But guess what? DARPA was not disappointed. They saw the participation. Particularly, there were 2 universities going head to head at the whole game. One was CMU, Carnegie Mellon University, and the other one was Stanford University. Okay, and then the next time they offered the same thing. It's called Grand Challenge 2, right? And they upped the prize money to $1.5 million. Now, to you and I, $1.5 million is a lot of money. But to DARPA, to the Department of Defense,
It's nothing.
they don't have precision enough to represent $1 million in the budget. I'm just kidding. I'm pretty sure they do, but but it's a small drop in the bucket. Okay. And guess what? Many of the vehicles in Grand Challenge 2 actually finished the race. So just one competition was enough to start the spark, to have all these universities trying to compete with each other. And the second one was very successful. The third challenge was called Urban Challenge. In Urban Challenge, all the autonomous vehicles have to drive in a city-like environment. They have to play by all DMV rules. Okay? So you would think, holy smokes, that is hard. Even I cannot do it, right? And guess what? They got really excellent results. The only part that has kind of hiccups was when they try to test the autonomous vehicles, like what if there's a parked car here that is not moving? Then the robots got kind of confused. Some said, well, maybe I should get around that car. Some said, well, just wait. So there was a little bit confusion there. But for the most part, they played by all the rules. They looked for pedestrians. They were respecting the traffic lights, stop signs, everything that we are supposed to do that we don't. Full stops at the stop signs, and so on and so forth. Okay, and yes.
What were they using, like something similar to facial recognition software?
There's a lot of stuff. They have a lot of dedicated sensors, like a LiDAR that can get a 3D image. It's basically kind of like a super Kinect. Okay, for those of you with the Kinect, LiDAR is a super Kinect. It can actually see in 3D, a 3D profile of what is in front of the car. But even with the hardware, the difficulty is not the hardware, it's the software. How do you process that information and get information out of that to determine what to do next? Okay? And so after maybe less than $10 million, now there's mature technology for autonomous vehicles. And Google has long have affiliation with Stanford University. A lot of professors at Stanford University also have a stake at Google. So they have a lot of close ties all along. And that's why Google has been using the same technology in their street view cars. And I drove by one once actually, when I was in the Bay Area. I was driving by, a Google car. It's really easy to tell because it has the camera, right on top. It's a Prius. And I looked, and it was nighttime, evening time. And I looked, I just took a glance, to my left, and I saw the driver doing this. Because the screen was bright, right? So you can actually easily tell, what the driver was, quote unquote, operator was doing, right? The operator was doing this, and then the car was driving itself. Wow. Yeah. And they have been doing that for years. They have been doing that for years. They just didn't let anyone know about it.
Is it legal? Is it legal?
Well, some people are now starting to challenge, whether it is legal.
Depends what state you're in.
Not that I'm challenging it, I'm just curious.
Yes, I don't think they're running into problems yet in terms of legality.
Because there's no
precedence. They don't have a rule for cars like that.
Well, you could use the distracted driver rule if they're using a laptop.
Depends what state you're in.
Well,
Some states you can use a cell phone and a laptop.